Yo, what's up guys, this is Magamu, and I've been sitting here working on my indie game, and I've been going through some of the comments that you guys left me to help me with the new enemy design, and I've been working on that pretty much for the last 2 days. Just to let you know, I did go through all of these comments. I've already started working on some of the enemy designs. I'm just putting that video together for you guys so you can see some of the designs and stuff I chose. But while I'm sitting here doing this, a much bigger topic has come up, and I feel like we need to talk about it because I need to equip you guys with some super helpful information that'll help you kind of learn more about game design, right? And mostly it's on the topic of Unreal Engine because both of my games use Unreal Engine. Now, someone in the comment section is panicking right now, like, oh no, Unreal Engine, I heard Unreal Engine destroys games. It's the worst engine ever. Games suck. And I know where that sentiment comes from. It comes from two distinctly different places. It comes from some of the games being, running very badly, in the last couple years. And a lot of YouTube videos that say Unreal Engine games suck because, right? Well, I'm going to help you out a lot because I have 5 words that I want to teach you that are going to really disarm this whole Unreal Engine sucks things, right? So if you don't even care about engines or you haven't been inundated with this information, essentially there are mostly three game engines that poor broke indie developers like myself use. I don't have $1 billion to go out and get some engine that's licensed by some company, then I have to, pay hundreds of thousands of dollars for support, etc. I essentially have 3 options of a game as a game developer, and all 3 options are good, right? By the way, I hope you guys enjoy this chill Sunday video. It's just going to be like a podcast, right? So the 3 options I have are Unreal Engine, Unity, and another one called Godot or Godot. So 3 of those. Now, I personally chose Unreal because it can handle some of the higher fidelity stuff, or at least when I started. But Unity has caught up in that aspect a lot. I know Unreal more than Unity, so I'm sticking to Unreal. And the third option, Godot or Godot, it has its advantages where it's a much lighter engine. For instance, Unreal is like 60 gigs for the base install. Godot is like 500 megabytes. So that's a huge advantage for Godot. But I've chosen Unreal Engine because for the last few years I've learned it. It does the very specific things I needed to do, and that's my choice. I've gotten used to it, I've gotten faster with it, and I'm going to stick with it. Now, why would I stick with it knowing all of the stuff that's said on the internet, right? So we've got all of these games that have come out that have been unoptimized, they run really bad. People who play on console are saying, my game's down to such and such frame rate. You got this smeary anti-aliasing. You got all of these problems on the internet. Why do I stick with Unreal? Well, the reason why I stick with Unreal is because I know that these issues don't really affect me. And I'm going to explain to you why these issues don't affect me and why these issues are avoidable. And I'm going to teach you about them, right? So there are 5 phrases I want to teach you guys, or at least, they're phrases. So you got Nanite and Lumen. These are features of Unreal. You've got shader compilation. This is a big issue with Unreal specifically, but it's solvable. You have draw calls. That's probably one you haven't heard yet. You have shader optimization, which you may or may not have heard yet. And you have this thing called tick, which is not really that big of a deal, but it'll help you understand, why games run so badly, right? So let's run through them. First of all, let's start with number 1, Nanite and Lumen, right? So Unreal Engine 5 introduced these 2 big new features, Nanite and Lumen. So essentially, Nanite is whenever you view something from really far away in a video game and then you walk up on it and you notice there's this flicker, right, where it's a really low poly and then it's a high poly model, that's called an LOD, a level of detail. Now, if everything in the world was rendered in the highest detail ever, like trees, your game just wouldn't run. Think about old, Far Cry games or whatever. Games just can't run with all that detail. So when something's far away, it renders, with very small number of polygons. When you're up close, renders high. But not only do you get that pop when you get closer, but also the artists who make the game have to do all of that work making 4 or 5 versions of that model so it doesn't just pop, right? As you get closer, it slowly eases in to the higher quality. Well, something like Nanite from Unreal Engine is supposed to solve that, because instead of them having to make all of those polys, it has one model, and then the triangles, it kind of deforms, as you get closer more smoothly. And they do that because the entire model is made of all these little triangles, and the triangles, they combine and they reconstruct. I'm simplifying it as you get closer and further, right? Now, the problem with Nanite is it has some performance issues. Like, for instance, there's this thing called overdraw. This stuff gets super complicated. I'm not going to get into it, but essentially Nanite has its own issues. Is it solvable? Yes, but it gets super technical. That's not the point of me bringing up Nanite. Let's go to Lumen, the second half of part 1. Lumen is short for global illumination. At least I think that's what it means. It essentially means, just like in real life when you go outside and touch grass. I know you guys have touched grass before. So in a video game, essentially light just hits an object. It picks up color, brightness, or whatever, and then it bounces back to the camera or to your eye, right? And you get an idea of what your world looks like. That's not how real life works. In real life, light can hit one object, bounce to another object, bounce to another object, and then it hits your eye. Now, as we get more realistic graphics, people are starting to expect that, right? So like, if a red apple is sitting on a table, you don't just get the apple reflecting back to you. You don't just get the reflection of the apple bouncing back, but there's kind of like red light scattering around. The problem is that's super expensive. Now, Unreal came up with Lumen, this super optimized way of doing that, but it's still expensive, man, especially when it comes to consoles, some low-end PCs, even some high-end PCs. Hardware just isn't there yet, right? So you get these games that have Lumen with this real-time light bouncing all over the place, and this Nanite with all this complicated geometry. And where this does benefit the gaming industry is they save a bunch of time not having to make those LODs by replacing them with Nanite, and not having to light a scene, test it. Sometimes it could take a long time. If you light a scene and then you process all those lights, it takes forever to make games that way. So essentially, Nanite and Lumen mainly save studios a lot of development time. Now, the problem with that is the end product you get runs worse. Now, here's the key that you really have to understand about these features like Nanite and Lumen. Remember Arkham Knight? I don't know if you guys remember. When Arkham Knight came out, and I'm pretty sure Arkham Knight's on UE4, I could be making a huge mistake. Let's just say it's on UE4. When Arkham Knight came out, it ran so bad, I had to refund it. I couldn't even run it. But now when we look back on the Arkham series, especially Arkham Knight as well, these games are viewed as some of the prettiest games for, that generation of consoles. The Batman games look amazing. Now here's the thing. What's the difference between UE4 and UE5? Essentially, UE4 didn't use all this bounce lighting and Lumen and real-time lighting stuff, and it looked amazing. The point is, developers can just turn these features off, right? So when people say Unreal Engine sucks, me personally, in the games I'm working on, I have just disabled Nanite and Lumen. So you're not even going to see Nanite and Lumen in my games. It's not the engine, because the developer can just turn those things off and create a beautiful game that they took time lighting, they took time making the LODs, right? So that's my solution, where I've just turned those features off. Now, if you're wondering, Mo, why don't you just go back with UE4? Because there are tons of tools, modeling tools, shader tools. There are so many things in UE5 that I need that are not in UE4, when I could just turn back the rendering to UE4, if that makes sense. So stuff like Nanite and Lumen. So it's not the engine, that's my choice as a developer, where I want you guys to be able to run my game on low-end hardware. So I'm going to spend more time making the models, I'm going to spend more time lighting the scene, and I'm going to make certain changes, right? Now, one trick that I did, I'm going to show you this, is, and I'm going to jump down to shader optimization here for just a second. So for instance, I had a light in one of my scenes. The light would bounce up into the blocks underneath my map, and it left this kind of like, it looked better, right? Because without that light, you could just walk into a hole on the map of my game because the lighting was just so flat. When I tried to use real-time lighting or even something like Lumen to naturally bounce that light into the scene, the frame rate tanked, because that light is expensive. So what do you do as a game developer when it's not just the engine, right? So I wrote a shader that behaved as if it was a light shining up through, so you could actually see the darkness in that block, right? Now that shader runs on the GPU, it runs in the shader, and it only processes once. So that's super optimized for my game. So not only can the player see where they're going, not only is the frame rate, not only can the player see where they're going, but the frame rate is also high enough that the game still feels good, and it's motion. It's 100 plus frame rate. I think it runs like 180 on my current machine. Like, it runs just fine because I made that decision to do the extra work to put the light into the shader. Now, a big studio may decide they want to save money and not do that, but that's not Unreal Engine. That's the studio making that decision, right? All right, number 2, shader compilation, right? Now, this is a big issue with Unreal, and this is a harder one to tackle. So one of the big problems with Unreal is shader compilation. If you guys don't know, shaders are essentially the little materials and textures that are on objects. The reason these things need to be compiled is because they're like little programs. On console, this isn't as big of a problem because, they could just pre-compile them for PlayStation. They could pre-compile them for PS4, PS5, PS5 Pro, Xbox, right? So those shaders are exactly the same. So they pre-compile them before they send them to you a lot of times. But on PC, we have all these different machines, right? So you can't pre-compile them. So now you have the shader compilation issue. When you first load up a game, either you get that long bar that's compiling shaders, or in a lot of Unreal Engine games that have problems, while you're playing the game will start stuttering. You'll go into a new town, the game starts stuttering. You'll get on your spaceship and fly off, the game will start stuttering. That's because those shaders are compiling in real time. Now, is this an issue with an engine? Well, the people who say it is will say, oh, this is a huge issue with the engine. Well, that's only part truth. This is about a 30% issue with Unreal, right? Because on one hand, mostly the blame goes to the developer, right? Because there are ways to get around this. You can compile shaders in a lot of games, like for instance, Apex Legends, right? Or I think Marvel Rivals does this. It compiles the shaders on the first time you run the game. So every time they put out an update, they have to compile those shaders, and then the game runs a lot smoother. But if there is an issue that lies with Unreal, and this is where I will blame Unreal. Unreal doesn't really give their developers an easy button, right? So one of the big sales with Unreal is it's an easy button. Here's your tree button. You press a button, here's tree. You press a button, you like smoke, press a button, and here's smoke, right? And that's on them, because essentially what they've tried to do is make Unreal do things with the press of a button. Well, there's no shader compilation button for game developers, right? So if I want to pre-compile my shaders so that you guys don't have to compile them every time you walk into a new area, it's very, very difficult. But with a little bit of research, a little bit of learning, I have learned how to pre-compile shaders. It takes a lot of practice. Like for instance, you can put those shaders in the map and then you do a loading bar and then you load those shaders up, right? That's one way to do it. You could actually load them before you start, which is essentially the same thing. But I'm sorry, I said that the wrong way. All right, so there are 2 ways to do it. The first way is you can physically put those shaders in the map, and then when you load the map, you load those shaders individually. So the shader compilation happens in the map loading part, and then those shaders are forever on your PC, or in the actual coding of your game, you can go through all of the assets in your game, check, what shaders are in the engine, and then compile those shaders before you allow the person to open the game. 2 very distinct ways of solving this problem. Epic does not stop you from doing it. So that's why I said it's about 60 to 70% developer fault, because they're not doing the work to pre-compile those shaders. They've got 2 methods, and it's about 30 to 40% Epic's fault for presenting Unreal as a press one button, get it done type of engine. And then one of the biggest issues, they haven't given the button, right? It still falls on the developer. Number 3, I'm going to introduce you guys to a new phrase. And this phrase is called draw calls. So essentially draw calls are, in the most simplest form, something gets drawn on the screen, all that stuff gets sent, throughout your PC. And every time something gets drawn, it's a call essentially across your PC. Well, those things can build up. Like for instance, if you've got a city and you're flying a helicopter over your city and there are 50 buildings, all of those 50 buildings are a draw call. So that's 50 draw calls on your PC, and it can slow your PC down. But it's not just that. Let's say each one of those buildings has, it has windows. They have windows, they have bricks, they have a roof, right? So let's say each building has 4 draw calls, which is nothing for a building. I'm just giving an example. Well, that 50 draw calls just went to 200, right? Now, a building is going to have a lot more than 4 draw calls. So now that 200 draw calls just went up to 2,000. And, now you've got dirt, you've got grass, you got a couple cars. Now you're at 5, 6, 7, 8,000 draw calls, or some ridiculous number. I've seen some pretty high numbers. That causes games to slow down, right? Now, I can't tell you every way to solve draw calls. I can tell you the 2 distinct ways I've solved draw calls in my games that have brought those draw calls down and have increased performance, right? And I'm going to mention the ways. Okay. Now I'm going to dox one of my games here that I haven't really showed you guys, but I have to show you this game to explain what we did. And by the way, I'm a 2-man team. I can't take credit for this. I have another person on my team called Cyber. It's the 2 of us. We're equal. And he's taught me a lot. I've taught him a lot. And we've solved these problems together. Okay. So in my other game, it is a procedural dungeon. It's almost like a horror game. It's a co-op game that you play with your friends. It's first person. And every time you go out into these dungeons, they are reproduced, right? They're completely different. They're procedural. The problem with this is 2 things. We have to make, one main thing. We had to make a map maker. Now, inside of that map maker, which Cyber created, it's a great map design. It's built right into the engine. We made it into a plugin. Is that you place all of the walls and, floors and all of this stuff into the map. So essentially it's like, Minecraft or Diablo is something we took a lot of inspiration from for building our map up with pieces. The problem with this is if you have essentially a hall with a bunch of wall pieces on it, guess what goes up? The draw calls. So in this instance, we were able to use, again, like I said, the stamps, the instant static mesh stamps. You just stamp them out into the game. You make copies of the mesh. We create the map designer that puts the data in. It tells where those objects are. And then that data is turned into those instant static meshes. So now instead of a wall being 20 pieces down a hallway, it becomes 1 piece. It gets sent through your PC and it becomes optimized. And now your PC thinks that it's just 1 wall instead of a bunch. The same thing happens with rooms. The way rooms are made is there are a bunch of floor pieces, there are a bunch of roof pieces, there are a bunch of wall pieces, but the floors get sent all at once, the wall gets sent all at once, and the ceiling gets sent all at once. So that something like 40 or 50 draw calls becomes 3 draw calls. So now the game is a lot more optimized and it runs at about 140, 150 frames per second on my PC when I run the game. I want to show you this room, for instance. This is another way of going about it. In this room, there's a floor, there are walls, and there's a ceiling, right? Now, this would be 3, 4, 5 draw calls because the floor, you got the columns on the outside of the room, the ceiling. But actually, this entire room is done in 1 draw call because the geometry is very simple. I project the textures in the direction of the surfaces. So there aren't a lot of curved surfaces in here. A lot of the surfaces are flat. So the only thing you need to know is what direction does the wall face, and then you project the texture onto that. And then you say, okay, if the projector is on the Z-axis, negative or positive. It's the surface on the y-axis, negative or positive. Project those textures there, and now you have a full room that's only one draw call, and it runs exceptionally well. And now you can put cracks in the floor. You can put things all around the room, and it's extremely optimized. You don't have textures and decals all over the place throwing the draw calls up on what is essentially just a box room, and it's extremely optimized. So that's shader compilation, optimization, that type of thing. And the last thing, which isn't as relevant, so in game design and especially in Unreal, there's this thing called tick. Think of tick as a clock, right? It's your frame rate. Every time your game generates a frame, we'll call it a tick. That's just the nickname. I have a great example of this. So in my game Sin Zero, the enemies take a swing at you, and then if the enemy is swinging at you, and then if you dodge, then you'll get that animated dodge where the enemy runs away at you, right? Now you ask yourself, how do you do this? How does the player know that the enemy is swinging, right? Well, there are two ways to do this. You can do it every frame, or you can wait for that event to fire. Now, in some unoptimized games, for instance, the developer might make the mistake where every frame, the player is checking if it's being swung at by an enemy. Am I being swung at? Am I being swung at? And then you dodge and but think about all of the computing you've wasted where every single frame that's generated in your game, if you play this game for 3 hours, every single frame is checking if the enemy is swinging at you so you can react to that, get the animation and swing back, right? That would be very unoptimized. What I've done is something that's more event-based. Now, I said this isn't a big deal because most professional game developers wouldn't make this mistake, but a lot of indie developers do make that mistake where it's constantly checking. But in my game, it doesn't constantly check. When the enemy takes a swing at you, the enemy sends an event to the player that basically says, hey man, I'm swinging my sword at you. What are you going to do about it? And then the player hits the dodge button, reacts, and then that message gets sent throughout the game. So everything in the game that needs to know that the player just dodged that swing, everything now knows. It's an event that only gets sent when it needs to be sent, and that optimizes the game. Man, I need to go back to work. I need a drink of water. I've talked for a solid 30 minutes. But the reason I made this video is because I've really enjoyed talking to you guys about game development. You guys have given me excellent ideas on my game. And if you start coming across these videos, I just want you to know, or at least I wanted to equip you with some of these phrases so you can kind of understand when, if someone says, well, Nanite and Lumen make Unreal Engine games suck and it's not the developer's fault. Well, the developer could just turn them off. You can still create beautiful games like Arkham Knight. You don't need Lumen. You don't need Nanite. And even if you use those things, there are ways to optimize them, and then you make sacrifices in other places so that the game runs well. I just wanted to show a lot of these phrases and help people to better understand what some of this stuff means. Because when you just say a piece of technology just sucks, that's not really a proper communication. Things have positives, things have negatives, and then there's the great in between. And when you start getting into the great in between, it's not useful to talk about these things without understanding the context of them, because Unity, Godot, and Unreal are creating some amazing indie games that without those things existing, there are tons of games that would just not exist. I think about things like Lethal Company that I recently played about 2 years ago, and I enjoyed it with a lot of buddies, but without something like Unity, Lethal Company just doesn't exist, right? And there will be a lot of good games that wouldn't exist if we just start, painting with a broad brush without understanding, what are the problems with these pieces of technology? How do we solve it? And how do we get good games out of it? And hopefully this helped you guys kind of build some context for that. Anyway, hope you guys enjoyed the video. Talk to you later. Oh, and I'm going to get you guys the enemy video. I'm working on it right now. All right, later, guys.